All right. Lesson 13, analyzing rational functions. So now all we're going to do in this lesson, it's going to be a quick one. We're going to bring in non-permissible values or holes. And you guys have seen this before too, so a lot of it should be a bit of review from 20-1. Okay, I'm just going to give you an example here. So let's do the example and I'll kind of show you what that would look like. So it says simplify this function. So if I was to simplify this function, really what I want to do here first is I want to factor this. So we're going to factor this as x minus 3, x plus 2, or x minus 2, sorry, over x minus 3. So you can see that one of these cancel, right? X minus 3 and x minus 3. So this would all become just x minus 2. So that's what that graph looks like. Now, x minus 2, like the last graphs we were doing, they were those weird ones with asymptotes here and there, right? X minus 2 is a simple one, right? The graph of x minus 2, it just has an or a y-intercept at negative 2, and then just goes up 1 over 1, up 1 over 1. So this graph would just be like that, right? Just a line. But if I looked at right at the beginning, like when I first started looking at this graph before I canceled things, this is the graph, right? Like this is the graph that I was looking at. And what number was I not allowed to divide by there? Or what number was x not allowed to be there? 3. Right, so x was not allowed to be equal 3. But we're not getting an asymptote from this graph. What we end up getting is what's called a hole or a point of discontinuity. And it's going to happen at the point, well, when x is 3. So it would be, when x is 3, it'd be right there, and we often just circle that to like an open circle right there. And it would show that x can be everything up, like it can be 2.999999999, like very, very close to 3, but it can't be 3. Right? So there's just like a hole missing in the graph. Or which is a point of discontinuity. If you guys use like zoom settings on your calculator, if you go zoom and then Z decimal is like one of your zoom windows there, it'll actually show like a missing spot on there too. If you just graphed like this whole thing, it would show like a missing hole on there too. So you can use that for a bit of a cheat if you want. Okay, so the actual point of discontinuity though for that one would be, okay, so when x is equal to 3, I got to figure out what y is. You can see pretty easily from my graph, right, what y is going to be. But if you had to do it graphically, you'd say, okay, when x is equal to 3, we'd say, okay, f of 3 is equal to, well, it was x minus 2, right? So that's just going to be 3 minus 2. So f of 3 is equal to 1. So the actual point of discontinuity, giving an x value and a y value, would be the point 3, 1. And then I did this a little bit backwards because I already drew the graph. So, okay. Next one here. So compare the behavior of this function and this function, noticing that the only difference here is this one's minus and this one's plus 2x. And then near any non-permissible values, and then explain any differences. So, all right, so let's do the first one. So we'll say f of x is equal to, and then I'm just going to factor this. So this would be x, and then x minus 2 over, and then 2. I'm just going to factor it 2 out of both of those, right? So 2, and then 2 minus x. All right. Can I just cancel those? No, they're not quite the same thing, right? X minus 2 is different than 2 minus x, right? In the same way that 4 minus 3 is different than 3 minus 4. So they're not quite the same, but here's a nifty little trick. What if I actually just factored out a negative as well out of this one? Right, so let's do this again. I'll say, okay, I'll leave that x. And I'm going to factor out like a -1, if you like, and then rewrite this. So if I factor the -1, what would that be? Well, that would be -x plus 2. over 2 times 2 minus x. Yeah, I'm just going to clean this up a bit now. This x times -1, that's really just negative x. And then I'm just going to swap the way that these look, right? Instead of negative x plus 2, I'm just going to rewrite that as 2 minus x over 2 times 2 minus x. Do you guys see what happened there? So if you run into this, this is like a nifty little trick that comes up quite often, that you can just factor out a negative to make those things work out to be the same when you go to cancel. Okay, so then those cancel. So we end up getting negative x over 2. All right, so the non-permissible values in this case, NPVs, would be, I'll just say NPV, would be at x is not allowed to equal 2. So what would your point of discontinuity or your pod be? I'll give you a hint. The x value is going to be 2. Remembering that this was our function. So what would the y value be when the x value was 2 there? Negative 1, yeah. So the actual point of discontinuity is going to be 2, -1. Okay. So now we'll compare that to g of x. So g of x is equal to, okay, so factoring this one will just be, so I'll factor an x out of that. So x and then x plus 2. And on the bottom, we've got 2 and then 2 minus x. And then I can't do anything there, right? That's like nothing's going to cancel at all here. So what is my NPV on this one? X is not allowed to equal 2. Yep. And then what's my, well, I guess I won't have a point of discontinuity. Where would my vertical asymptote be? So vertical asymptote, so straight up and down, is going to be at x is equal to 2. Okay, so do you guys see the difference there, that since we didn't cancel that one out, we didn't have a point of discontinuity? So just know when you have each type, right? So when you cancel it out, it's a point of discontinuity. If you don't, it's a vertical asymptote. All right, last question. Match the equation of each rational function with the most appropriate graph. Give reasons for the choice. Okay, so let's factor this again. So we're going to factor the top. That would be x times x plus 2 over, ooh, how do we factor this guy?
It's x minus 2x plus 1, or x plus 2x minus 2.
Yeah, it's a difference of squares, right? So we can write this as x minus 2 times x plus 2, and they cancel, right? So we end up canceling. So this ends up being x over x minus 2. So now we'll just talk about it, like looking at this one. What am I expecting here? Well, just this graph on its own, the way it would actually look, where would I have a vertical asymptote? 2, and only one of them, right? There's only going to be one vertical asymptote. So just narrowing this down, which one is it going to be? It's going to be graph 2, right? So I'm going to have a vertical asymptote at 2. But then I'm also going to have a point of discontinuity at x is equal to at -2, right? Which makes sense. That's drawn as a little hole on our graph, right? So that's be our point of discontinuity there. Okay, so let's do the next one. So factoring this would be factor of the 2 x plus 2 over, and then can I do anything here? No, can't really do anything. Now here's the question. So looking at this one here, what values of x are not allowed? Yeah, is there anything that I even could throw into there that would give me 0, right? So if I threw 0 into that, well, that would be 0 plus 1, that's still 1. If I threw a negative into there, The negative would become positive. That's still like it's never. There's nothing I can throw into that that's going to make it work out that way. So which of these graphs would most likely be the case then?
The one without any.
Yeah, the one without anything going on there. Yeah, so it ends up being kind of a weird looking graph. You could also, right, using some of our algebra, we could throw in 0 in for our x's there, and we'd have 4 over 1 if you simplified that for a y-intercept, which makes sense. We cross at 4. Right, so there's other ways you can do it too. You can find your y-intercepts or your x-intercepts. Okay, and then lastly, looking at this one, we've got 2x over, and then this is just x minus 2, x plus 2. So I'm expecting to have 2 vertical asymptotes at
2 and -2.
2 and -2, right? So the only one at 2 and -2, so that one there.